Are there questions that you wanted to go over from the parabolas where you're writing the equations? There we go. You got stuck with? Want to discuss how to come up with some of the equations? Harris.
79.
Why didn't you sign up for a math class?
I'm in stat.
This year?
That's next year.
I didn't see your name unless I didn't. I just didn't write it down.
She was about to kill you for us.
I was. Okay, so I just didn't write it down. I gotta go look. You're the only one I don't have anything written next to. I'll look again.
She was really about to come at your neck. I'm okay with that. You know? I'll finally get some sleep.
Okay, so say again, number?
79.
79. I'm not sure if I believe you yet. I'll go look.
She told me. I can second that.
I might just not.
I mean, that's what I clicked, so.
I had like 6 different pages I was like
It
going
might
through.
be under electives. She might have signed up for under electives.
Okay, I'll go look. Alright, so number 79 says write the standard form of the equation. You have a picture of a parabola. Looks like it's going down, vertical. How would you start to come up with an equation? Brandon?
So you have, say, write down the vertex, for rate 3, 1. I
So-
just basically rewrote it.
Okay, so the vertex is 3, 1. And Brandon, if it goes down or up, what do you know about the standard form of the equation? What would it look like?
X is squared, and since it's going down, P is negative.
Right. So because it's going down, our p-value has to be negative, and x is squared, because that's the form of a vertical parabola. What else can we use, Chelsea?
The point you can plug one in for that.
Yeah, it doesn't matter which one?
No.
No. Either one, it doesn't matter. Chelsea, which one did you plug in?
The 4, 0.
Okay, so you have a point at 4, 0. It actually happens to be an x-intercept, but as long as it's anywhere on the parabola, it represents x and y. The vertex of the parabola would be the h and the k. And Brandon said that the p, that we need to make sure when we get our end equation, is negative since it's going down. So we plug in all our information. X is 4, h is 3. We have this 4p. We don't have anything to plug in for that. Y is 0, and k would be a 1. So Brandon, then what?
You do 4 minus 3, which would be 1, which is equal to 1, is equal to 4p, times negative 1, which would be negative 4, which would be negative 4p. So 1 equals negative 4p, divided by 4, p equals negative 1.
So here's my question. Do you, you said p is equal to negative 1/4. Do we need to know p?
No.
No. So you could just stop when you get to the negative 4p part, because we don't need to know p, which is negative 1/4. We just need to have that negative 4p value. So you don't have to get p by itself. So Brandon, what does that mean then for our equation? So we would have x minus
We'd have x minus 3 squared,
equals 4 times p is
negative 4, negative 1,
negative 1, and then y minus 1. So checking to make sure it looks good. P is negative 1, or 4p. The number in front here is negative 1. We said it needed to be negative. We found p to be negative 1/4, but you wouldn't have needed that number. If you find it, it's okay. Just multiply it by 4 again. So that equation, x minus 3 squared equals negative 1, and then y minus 1. Or just negative in front. You don't even need the 1. Virginia?
It's kind of like a question, but why is it 4?
That, like, it's just one of those numbers that was derived to, like, just like the quadratic formula. Why is there's a b squared minus 4ac divided by 2a. Like, those numbers are just there because they were derived. Somebody found a pattern, and the only way it works is having that number there. But the number in front that -1 is actually the distance that you would travel to go left and right from wherever your foci value would be. Other questions from the homework? So today we are going to do the third conic, and that would be the ellipse. The circle and the ellipse are similar in that they both have two square terms because they're both like enclosed figures or shapes, whereas the parabola just has one square term because it's a U that goes up, down, left, right. So in a sense, it's almost like we have two parabolas that are kind of like connecting out of space, yeah.
Is it possible to have a parabola that goes diagonal?
Yes. Yes, because it goes on like a separate axis, almost like it lies on like a line.
Are we gonna be doing that this year?
We are not going to be doing that this year.
Next year,
If you don't do it in AP, AB, you'll do it in BC. You'll hit it at some point. Any questions? In your packet then, if you'll turn to page 11. Yeah, Brandon, the slanted parabola adds some prime symbols to it that having some calc information, derivatives and stuff helps a little bit. We could still mathematically do them without that, but. And I bet I think if you go in the, maybe it's section 9.4 in your book, I think it talks about a little bit. So the ellipse would be the third conic, which means we have one other one to talk about next week. We'll go through the general information, what parts of the conic we need to look at, how we can find the special parts like the vertex and the center and all those pieces today. We'll look at the general or the standard form, so what the equation looks like, how does it change vertically versus horizontally. We'll look through a whole problem. And work through the problem. Those 5 problems at the bottom, underneath 37, 38, 39, 41, 45, those are the 5 problems that are going to be like the 5 involved graphing problems. The ones above it are just matching. So really you have 5 problems for homework tonight. But they're pretty involved because there's good information that we find with the ellipse. Tomorrow we'll finish, so we'll do like one example tomorrow and we'll talk about something called eccentricity. And then you'll have some time to work in class tomorrow. And right now, I'm like trying to figure out the next 2 weeks up until our spring break, so that we kind of know where we'll be going. But right now, I have a test next Friday for conics.
For that Monday that people are missing.
That's what I'm working on right now. I have to try and figure out like, do I give that test on Thursday and start new on Friday? But I don't know. I'm trying to figure that out. Mr. Cummings says that's what I should do.
Thing where we take the test on, or we take the test on Friday, but we do a mini lesson on Thursday.
Oh yeah, we can do that too.
I prefer that. We do a mini lesson on Thursday.
So the next topic we're talking about is parametrics, and like it's kind of important for you guys to be there for the first day. And if I'm missing like half my students on the first day, it's a little rough to learn on your own because you've never done parametrics before, just like you've never done conics before, kind of thing. So I have to try and work that out myself tonight, tomorrow, sometime soon. All right. So an ellipse, it says the set of all points. That's that part of every conic that we looked at, that part that's like the locus, and then they have to meet a certain geometrical property. The property they meet, it says the sum of whose distances from 2 distinct fixed points, called foci, is constant, which sounds like crazy word jumbled, all this stuff in there. I'm going to draw a little graph up above, just for you to kind of visualize what it is. You don't have to draw anything. Save the space underneath the definition because I want you to be able to draw 2 nice big graphs. So an ellipse is an oval. Ooh. Try again. So think of the path better that the Earth takes. We call it is the elliptical, right? It's an ellipse. So it's not a circle, it's not a true circle, but it's more of like that oval elliptical shape. So that's what we're talking about when we say an ellipse. However, the way that it's formed is based off of these two special points. Instead of having one focus, we have two of them. And they are inside. And they're going to be the same distance from the edge. So if one has like 2 spaces from the edge, the other one will have 2 spaces from the edge. Those are called our foci points. So each focus here. So now we have 2, where a parabola had 1. So what this is saying is that if you have a point, any point on the edge, that's for the set of all points, somewhere on the edge of the ellipse, if I take the distance to get from the point to one focus, whatever that distance happens to be, and the distance to get from that same point to the second focus, and add those two distances together, no matter where you are on the outside of the ellipse, that distance is the same. So I could be here and traveling to the focus, to the other focus. If the distance is 12 once, the distance is going to be 12 every single time. So whatever it takes for me to get to those 2 points, if I add that sum together, no matter where I am on the edge of the ellipse, it'll be exactly the same every single time. At the bottom of your page, and this is what, when I woke up at 3 o'clock, I need to have a piece of paper next to me, and I don't. And I wake up in the middle of the night all the time. And then I think of things. I wanted to grab my yarn. Sounds like old school that I have yarn, but my girls, not me, I don't sew. My girls like to make those little puffball things. So I have yarn. And I had it in my mind that I was going to grab the yarn so that I could show you on my very small bulletin board over there. But at the bottom, trying to get you to like visualize, it says, visualize an ellipse by having 2 thumbtacks placed at the foci. So if I could take both pieces of string and just thumbtack them into my bulletin board and have it like the string, yarn wrapped around a pencil so that they're glued in and secured to my bulletin board, and then I would just kind of pull the string tight and force it to go around, and it would end up making an oval figure because my string is like, I don't know, 18 inches in length, and using that 18 inches, it's just going to spin me around and get some kind of oval. That's how, like, kind of want to think about it. So if anybody has a cork board at home, ooh, Kate has a cork board?
We did the same thing in physics.
Oh, good. Does he have he brought in string?
Yeah, we just set it on a cardboard box and we put on a piece of paper on it.
And it works, right?
Yeah.
See, now my mind, Mr. Shaw.
California.
Oh, he's way better than I am. He doesn't have a female brain, I'm gonna go with that. Female brain sometimes is not a good brain to have.
Neither the male at times.
Because after you become a mom, you forget everything.
A guy brain, you walk through the door, you take off your shoes, and all you want to do is sleep.
Well,
That's
that's
I had that brain.
yeah. I think all of you have
It's
that
a
brain.
brain.
Okay, so that's like, if you have cardboard at home, so you don't have to have a corkboard, feel free to, and yarn, or string, or twine, anything like that, try it. Just don't do it in your hardwood floor. Because if I were your parent, I would be like, your teacher told you to do what? And I don't want to get blamed for that. Holes in your hardwood. Or wall. It would work in your wall, but don't do it in your wall either.
What about the ceiling?
No.
Then how are you gonna reach the ceiling?
Yeah.
Stand up. Stand
All right,
up,
so
that's all.
we're going to start with the horizontal because I feel like thinking about X is a little easier. And this has a special name. It's called the horizontal major axis. So if my major axis, the main axis that goes horizontally, which has all the information on it, that makes it a horizontal major axis. So the main part of the graph is going horizontally. Make yourself a nice graph because the other one's going to go vertical and you don't need as much width going vertical, but you're going to have a lot of stuff to label in here. So make it a little larger so they have the space to label some things. There are 4 little tick marks below that we are going to locate on our ellipse. So we have vertices, which says 8 units from the center. So we're going to grab that first, but we probably need a center first. So in the middle, as best as you can get the middle to be, place a point, and we're going to call that the center. The center is still H and K. Will never change. The center of a circle is HK, the vertex is HK, the center of the ellipse is HK. And it's in the middle of the ellipse. So I could take this ellipse, cut it in half at the center, and I will have the same things on the left and the right. They'll be identical to each other. So it says our vertices are A units from the center, and they're going to be on this horizontal line. So I'm just going to dash in an invisible horizontal line that connects the vertices and the center together. So here is a vertex and another vertex. The distance from the center to each vertex is a distance of A. Mine doesn't quite look centered. So if I go from the center and I move left A and right A, I now have the whole length of the ellipse. That's how I can get the width of the ellipse, not the length of the width. That entire distance is the major axis. So when we talk about the horizontal major axis, that distance going left and right, that whole thing is our major axis. So the major axis should be the longest one, hence the word major. Everything lies in there. All right, so now we have vertices, A units from center. Underneath the major axis, it says its length is 2 times A. And that makes sense because I have two A's, one on the left, one on the right. You double it, you get 2A. So its length is 2 times A. Part 3, we want to find the minor axis. Where do you think the minor axis would be? Brandon? Going vertical, because it has to be whatever's left, and the other way would be to go up and down. So again, we kind of have like this imaginary dashed line. It says the minor axis, which would be the smaller one, is 2 times B. So my distance will have a number to represent B. From the center to the other edge is this distance of B. Or from the center up. So that would be the height that we're trying to find. And that's going to be a number B that we'll have in our equation. So now there's 1/3 letter because we have 3 letters to actually deal with. And that third one goes along with the foci. And it says it's C units from the center. That lies on the major axis. So everything's going to lie on the major axis. So somewhere, pick it over here. We'll say that's the focus. Try and make yours the same going the other way. It doesn't necessarily need to be directly between the vertex and the center. It's just going to be somewhere in the middle there. So here's a focus. That distance is C. So if I go from my center to the focus on the left or to the right, I have C. So now I have a crazy drawing because it has all this stuff labeled on it, all these squiggly little braces lines. But all of that makes an ellipse. So 2 vertices, 2 foci. The B value gets me the other direction so we know how wide it is. So with a parabola, we plugged in a number from the focus to help us get the width of the parabola. Now we'll have a number in the equation that helps us get the width. We won't have to plug in any extra things. Underneath, I want to list 2 things because we will have to talk about how to get these. So the vertices and the foci. So if the graph is going left and right, how do you think you find the vertices? Thinking that it's A units from the center. How can I write a little equation or formula? Let's say formula to represent that. Chelsea? Yeah, well, not even easier than that. What is the midpoint of this graph? What's the center of the graph?
Oh,
H and K. It could be 0, 0, but it's going to be H and K. So if we start at the center, Chelsea, what do you have to do to get out to the vertex? What are we adding to get there?
Oh, like H plus an A.
Yeah, H plus an A. Or if I go the other way, I could have H minus A. So I'm starting at the center at my H value. If I add A, I get to the right point. If I subtract A, I get to the left point. The K isn't changing because everything that's changing is horizontal. So then the foci are just adding C. And then again, the K isn't changing. So if it's a horizontal graph, my points should all be moving horizontally. Questions? So see if you can flip that graph, make yourself an oval going up and down. And we'll try and label those parts.
It's hard drawing.
It is, especially big. I mean, like, this is what, an 18-inch oval that I have up here? Maybe more, maybe closer to 2 feet. It's hard. So just try and label the same pieces of information, except now the things should be going vertically. So you still have this major axis going the whole way down, connecting the center and the vertices from top to bottom. And then that distance is A. The other way, now left and right, the width to go from the left and the right is B. So B would be always the other direction to get you how wide it is, how tall it is, depending on which way you're looking, graphing. And then the last thing, the focus, it should be the same distance going up or going down, that distance of C. So Virginia, how do you think you'd find the vertices if it's going up and down? Yeah. Because now the y values need to move. So I'm going to take my center value of k, and I'm going to get there, and then we're going to go up 3 and down 3, or up 5 and down 5. So then we would find C, C. Any questions? So there's one thing that I need us to write before we flip and look at the equations, and that's actually how do we find C? So underneath here, C squared is equal to A squared minus B squared. And I'll kind of tell you why as we look at the equation. But we're pretty much taking the two distances, the major axis, which is the longer one, subtracting the shorter one, and that those two values then give us the distance that C would be from the center. So we're going to look at the equations so you can kind of look to determine where all that information is coming from. And that's on the top of the next page because unfortunately I couldn't fit it on there. So if you flip to the top of the next page, we'll do the horizontal one on the left side. And the vertical one on the right, just so that it's the same as what we have on the previous page. Does anybody remember how the circle went? Kate, do you remember?
X squared plus y squared equals r squared.
So she said x squared plus y squared equals r squared. And Kate, if we throw in h and k, then it would be?
X minus h plus y minus k.
Yeah. So that was the equation of a circle. The equation of an ellipse is similar, except we don't have a radius that's the same all the way around. So instead, there's going to be a number 1 over here. There isn't an r squared because the radius takes me the same direction anywhere from the center. We need to have a and b. And a and b are going to be in the denominators, but they're actually squared values. So everything is squared. Just like r is squared, it's still squared to get us that kind of enclosed shape. The most important thing to know that it's going horizontally is where the bigger number is in the denominator. A squared is our larger value. So if the larger number is under x, it goes horizontally because it's going to stretch further left and right if the x has the bigger number underneath it. For the vertical form, it is exactly the same. But now the bigger number is with y. So a is the biggest number, bigger number. B would be then the smaller number. So after you work through, we're going to complete the square. Wherever the bigger number lies is the direction that it goes. 8.
I don't know if this matters, but what happens if they're equal?
And it would be a circle. So it does matter. So if it's equal, then we have this circle. Right.
Why are you allowed to just take the square root of everything, just have x minus h over a? No.
You can't individually take the square root of pieces of the equation. You can take the square root of the whole thing. You can't separate and because of the addition sign. So I can't just individually take square roots of parts.
So you can't take the square root of the entire equation?
I can, yeah.
Would that mess up or no?
What do you mean mess it up?
You could take it further, but you couldn't simplify it like that.
It wouldn't get you anywhere. You'd still have a plus or minus in the problem.
Okay.
So to get y by itself, if you're trying to think, can I get this in y equals form? I don't know why you'd want to get y by itself because it wouldn't, in the long run, it'd do more work. Because then you just have to use a t-chart and plot points with a t-chart. Other questions? Out of the what? Oh, so there's a special axis that it lies on. So the equation has extra parts in it to get us the special axis that it's lying on. So it's almost like it lies on a line of y equals x. So it has its own slope and then it lies on that slope. Other questions? So if you look at the problem underneath, find the center, vertices, foci, and of the ellipse, and then sketch the graph. So very similar to this circle. So think of when we did the circle, which was on Monday. What would you need to do with this information to try and start doing something to find some pieces out? Michael? Yeah, we need to complete the square. And in order to complete the square, Michael, is there anything you have to do with all of these parts? Yeah. We move that 8 to the other side. So that number that's by itself, move it to the other side. Michael, what do you notice about the two x terms? Yeah, so the two x terms have a 4 in common. Remember, if there's a coefficient, you need to take that coefficient out of the squared term. So we'll pull the 4 out of the x. The y's don't have a value. There's nothing in front of y squared, so we don't need to pull out anything from y squared. And we got that 8 on the other side. So Libby, the next thing we're supposed to do to complete the square.
So you would do -2/2 squared, and that would be +1.
But on the
Then
other
you-
side,
That would be +4.
good.
And then you would do, that would be +4. But, since you would do 4 over 2,
4 over 2 squared is
2 squared, which would be 4.
Yeah.
And then you would do 4
Yeah.
there.
Good. And then we factor it. So one more step here. This factors as x minus 1 squared, y plus 2 squared, and it's equal to 16. So looking at your standard form, just look above, so it's right up there. in standard form? Not yet. Chelsea, why isn't it in standard form?
Well, there's value before x and
Yes.
it doesn't equal 1.
Exactly. So there's a number before x, and it doesn't equal 1. How would you get it equal to 1?
You divide by 4. Actually, no, divide by 6.
Yeah, so if we want this side to be equal to 1, we have to get rid of it by dividing by 16. So we're not subtracting it, because then it would be 0. We have to divide by 16. Chelsea, what happens when you have 4/16?
It simplifies to 1/4.
Yeah, it simplifies to 1/4. Now there's a 1 in front of the x squared. There's not a number that was with y squared, so that's just going to stay 16 on the bottom, and it's equal to 1. So Kate said, what happens if they're the same? If those numbers happen to be the same, then we have a circle. It's okay, we can still work through it the same way. But if there's a coefficient in front of one of them, then they're not going to be the same. What direction does this go? Yeah, this is vertical. Here's our bigger number. So this is our a squared. That one there is our b squared. This is going to be a vertical graph.
So these are vertical being like x squared.
Now,
Why did that have to change? It was working so fine the other way.
I know, I'm sorry. So before we actually graph this, the bigger number is a squared, but we need a because the vertices are a distance from the center. So this is a squared, a would just be 4. B is the distance of the other way, so it gets us the width. B squared is 4, B is just 2. I need one more letter, I need a C. How can we find C? Brandon?
C squared equals a squared minus b squared. And that would, c squared would equal 12,
Yeah.
and then it would be 2 times the square root of 3.
Thanks, Brandon. So you're taking the denominators and subtracting them. So the distance of the major axis minus the distance of the minor axis. They're already squared. So you're just taking 16 minus 4, and he said that would be 2 square root of 3. So now see if you can get the center. Start with the center. You might need to flip the page to help you figure out how to calculate those vertices. I'm going to pass out some graph paper for you. So remember, this is vertical, so look at your vertical graph. Oh, Chelsea, you even saved space for a graph.
I know.
I'm impressed.
Kind of squeezed it all on one side of the
Well,
paper.
if you save space for a graph, that's fine.
I didn't.
I'm thinking some of you don't have space for a graph. Question?
Why isn't like a and b value plus or minus? Because you take the square root.
Because it's still I mean, in theory, you're going to be adding it and subtracting it to go up and down, but it's still a distance. And since it's a distance, it's just a positive distance. So but you are going to be adding it and subtracting it to find the vertices, because you're going to add it to go up, subtract it to go down. So your center should be 1 and -2. To find the vertices, because it's vertical, your y value is changing. So Jenna, I mean, in theory, we are adding and subtracting 4. So one vertices should be at 1 and -6. A second vertices should be at 1 and +2. So you really are adding 4 and subtracting 4 to go above and below the center. Because the foci value is not a nice number, you can just leave it as -2 ± 2 square roots of 3. That can't really be simplified any further. So on your graph paper, see if you can try and plot those points, starting with the center at 1, -2. We said A was 4, so from the center, I'm moving up 4. That gets me to my highest vertex. From the center, I'm moving down 4. That gets me to my lowest vertex. That's what A is. So it is technically a plus and a minus because you're moving up for the plus, down for the minus. The B value is 2. That goes the other way. So go back to your center. Go 2 to the right, 2 to the left, and then that gives me the width. So A is up and down because we said it was vertical. B is the opposite direction, that gets us the width. And then the last part is the C, which gives us the foci, and that's the square root of 12, 2 square roots of 3. How could you guesstimate what that is, Brandon?
The square root of 4 is 2, so you're going to be just a little bit over 2, under 2, and then multiply that by 2.
Okay, so you could do it that way. What other way, Kate?
3 squared is not equal to 16, so it would be
Right. So Brandon, I see where you were going with the rationalized one, but like the square root of 12 is in between the square root of 9 and the square root of 16. So it's going to be in between 3 and 4. So go back to your center. Everything's based off of the center. Go up 1, 2, 3, and a little more. Kate said it had to be in between 3 and 4. Go to the center, down 1, 2, 3, and a little more. Everything is from that center point. Try and connect them to make them look like an oval. Mine always end up football shaped. So take your A, if it's vertical, up and down. B, left and right. So use those A, B, and C values. Once you have them listed, I strongly suggest you just listing those on the side of your page. Everything is counting from the center. So again, 5 graphs. It'll ask you to describe the eccentricity. Ignore that. We'll talk about that tomorrow.
That's a weird
Oh, this C?
Yeah.
So the formula is
Oh,
C squared equals A squared minus B squared. So the difference of the denominators. Other questions? Have a great day.